Morse code is one of those interesting pieces of history that still captures our imagination. For ages, it was super important for everything from wartime communication to early radio. Morse code is a cool technology, a great way to understand how information can be encoded and transmitted. This guide is perfect if you're just starting out with Arduino, if you enjoy playing with electronics, or if you're simply curious about how things work. We'll assume you've got a basic handle on what an Arduino is, how to hook up simple circuits on a breadboard, and that you've played around with a little bit of Arduino code before. Don't worry if you're a complete beginner. We'll take it step by step. By the end, you'll have a light flashing dots and dashes like a mini telegraph station. First, some background on Morse code. Morse code was developed in the 1830s by Samuel Morse for telegraph communication. It uses a series of dots, short signals, and dashes, long signals, to represent letters and numbers. For example, the letter A will start with a dot and end with a dash. B will be dash, dot, dot, dot. The numeral, 1, will start with a dot, then follow with 4 dashes. When we program our Arduino, we'll use timing rules to control how long the LED stays on and off. It's a great way to practice precise timing in code. A dot's timing is 1 unit. We could set 1 unit to last for 200 milliseconds, for example. A dash is 3 units, or 600 milliseconds. The space between parts of the same letter is 1 unit. The space between letters is 3 units, while the space between words is 7 units, or 1400 milliseconds. To put things together, here's what you'll need. An Arduino board, Uno, Nano, or any model you have. An LED, any color, can also use the Arduino's built-in LED on pin 13. A 220 ohm resistor. This protects the LED from frying. Trust me, I've killed a few LEDs by skipping this. A breadboard to make life easier, connecting everything together. Jumper wires for making the connections. Links for these items can be found in the video's description below. You will also need the Arduino IDE software, which you can download from arduino.cc/en/software. If you're new to Arduino, the built-in Blink example is a great warm-up before diving into Morse code. With everything ready, start by building the circuit. Connect the LED to the Arduino. Connect the cathode, short leg, of the LED to ground. Connect the anode, long leg, to a 220 ohm resistor, then pin 13. Pin 13 will also trigger the Arduino's built-in LED. So this example will actually work without an extra LED. The resistor is crucial. Without it, too much current would flow through the LED, and it could get damaged. Double-check the connections. Resistor in place. LED legs correct. Wires snug in the breadboard. Once you've got everything wired up, plug your Arduino into your computer using the USB cable. Now, the fun part, coding. We're going to write some code that will translate letters into their Morse code equivalents, and then blink the LED accordingly. The full source code for the Arduino sketch is available on GitHub. The link to the repository can be found in the video description below. Step 1. Define Morse code. Dictionaries. Each character is stored in a byte array, 1 byte per character. The bit order for each byte represents the dots and dashes that will need to be blinked. The first 1 bit in each byte represents the start flag for the blink sequence. The first one and preceding zeros will be dropped. For example, the letter A is represented with 5 zeros followed by 1 0 1. The bits will be shifted, discarding the 5 preceding zeros and the first one. The remaining bits, 0 and 1, will be blinked out. A dot for 0 and a dash for 1. Step 2. Create blink functions. Now, let's create functions to blink the LED for a dot and a dash. Here we have a helper function called blink delay that works just like Arduino's standard blink example. We use digital write functions to set the digital output pin to high, typically 5 volts, then back to low, 0 volts, effectively turning the LED on for a set duration. The send dot and send dash functions are configured to call the blink delay function for 1 and 3 units of time, respectively, as per our Morse code timing schedule. Step 3. Convert text to Morse. Now for the core logic, converting a character to its Morse code and blinking it. If the character is a space, the function will simply delay blinking for 7 units, the standard delay between words. Otherwise, the function will loop through our Morse code dictionary until it finds the corresponding bit sequence for the character. From here, each bit is shifted until the start flag is found. Once found, subsequent bits are shifted until the end of the sequence, calling out send dash or send dot functions accordingly to blink a dot or a dash. Again, the full source code for the Arduino sketch is available on GitHub. The link to the repository can be found in the video description below. Step 4. Putting it all together. Finally, let's put it all together in the setup and loop functions. We'll start by sending the message "Hello World." The loop function will pass each character in the message to the send Morse char function, repeating the message. Again, the full source code for the Arduino sketch is available on GitHub. The link to the repository can be found in the video description below. With the code finished, upload the sketch to your Arduino board. If all goes well, your LED should blink "Hello World" in Morse code. Common issues and fixes. LED not lighting up. Check polarity. Long leg to the digital pin short to ground. Ensure resistor is properly connected. Timing feels off. Adjust delay values until it looks right. Code errors. The Arduino IDE will highlight syntax mistakes. Read them carefully. Now that your LED is fluent in Morse, let's explore some potential modifications. Add a buzzer for audible Morse code. Here, you would replace the digital write functions with tone functions. Use serial input to type custom messages. Use serial.readString. Build a Morse decoder with a light sensor. Advanced but super cool. Congratulations! You've just built a device that communicates using 180-year-old technology. Not only is it a great exercise in hardware and software integration, but it's also a quirky reminder of how much you can do with just a few components and a bit of code. You've taken a step into the world of encoding information with hardware, which is a fundamental concept in electronics and computer science. From simple blinking lights to complex digital signals, it all boils down to representing information in different ways. Projects like this are where a lot of makers fall in love with electronics. They're simple, satisfying, and they leave room for endless tinkering. Go forth and tinker. Try new messages, experiment with different outputs, and maybe even learn Morse code by heart. Who knows? Maybe one day you'll use it to send a real SOS. Over and out. For now, happy coding.